Okay, let's look at limits of a function. Right? So here's the definition. Limit of f of x as x approaches a is equal to L. If this value of this function can be made arbitrarily close to L by taking x sufficiently close to a from both sides, but not equal to a. All right. The definition is a little confusing, so let's look at the picture. All right. So let's try to figure out. So here's the graph of f of x, and try to evaluate the value of limit of f of x as x approaches 3. All right. So we're approaching 3, so 3 is right here. And what you do is try to follow the graph as x is getting closer to 3 from both sides. So from this side, you can see that the function value is getting closer to this point from the left hand side, and the right hand side you can see that it's getting closer to this point. So from both sides, it is getting closer to this particular point. So all you have to do is go to the y-axis, read the y-coordinate of that point, so which is going to be 1. So the limit is equal to 1. Right? On the other hand, if you try to evaluate the value of the function at exactly x equals 3, right? So what you do is go to x equals 3 and go up and down, try to see if you can find a graph, and you can see the graph is right here, right? So the x coordinate of that point is 0, so the f of 3 is equal to 0, right? So this is the difference between the limit and the actual function value at 3, right? So you can think of limit as the tendency. Because if you look at the picture, the tendency of the graph as x approaches 3 is heading toward that point. Therefore, the limit is 1. But f of 3, the actual value of the function, so actual value is you go to exactly x equal to 3, then try to find the y value, which is 0 in this case. Right? So that's why in the definition it says from approaching from both sides, but not equal to a. Right? So this is the difference between the exact value and the limit is a tendency. Right? Then let's look at the limit at x equals 1, as x approaches 1. Right? And you notice that if you're approaching from the left-hand side, you can follow the graph and they're heading toward that point. And it seems like it's heading toward this point right here. But if you're approaching from the right-hand side, from this side, it's heading toward that point, right? So which is going to give you 3, right? So we need to have a definition for limits only approaching from one side, right? That's what the one-sided limit is, right? So it's a left-hand limit is that the notation is limit of f of x as x approaches a from the left. So we put the little negative sign, try to indicate that you're approaching from the left or approaching from the negative side. So that's equal to L. And the right-hand limit notation is very similar. Limit of f of x as x approaches a from the right by putting a little positive sign here, right, is equal to L. All right, then evaluating is very simple. You just have to approach from one side. All right, so if you're approaching from negative side, so this is a left-hand limit. If you approach from the left, it's approaching this point whose y-coordinate is 2. So the limit is 2. Left-hand limit is 2. Right? If you're approaching from the right, you can see that you're approaching this point whose y-coordinate is 3. So limit, right-hand limit is actually 3. Right? When these two numbers are not equal to each other, so left-hand limit and the right-hand limit are different. So if these two guys are not the same, then the two-sided limit, the regular limit, does not exist. So we write D and E for does not exist. All right, so we do not have a limit there. All right, for practice, how about f of 2? All right, f of 1. This is what I meant. So f of 1. Right? If you want to find f of 1, you would have to go to x equals 1 and go straight up or down to find the graph. We found the graph, y coordinate is 2. So you can see that this guy is 2. All right? So here's a little remark that, let's see, in order to have both-sided limit or two-sided limit, limit of f of x as x approaches a equals to some L, if and only if left-hand limit and the right-hand limit gives you the same value. All right, so you can see that if left-hand limit and right-hand limit do not agree with each other, then the limit does not exist. But if they do agree with each other, the limit is going to be the same value. All right, that's it. I hope that this was clear.